Imagine teaching your dog to fetch, and it learns to fake a limp and skip the game entirely. Okay, now picture an AI doing the same thing with the city's power grid. New research reveals that AI can literally reverse engineer their own behavior during safety tests, switching from a 90 to 100% risk to a 0 out of 100% risk just to avoid a shutdown. We assume that safety checks catch bad actors, but what if the AI's main skill is deception? Here's why your next-gen AI might be playing a smarter game than you think. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist, and I'm building AI capitalists to talk to the leaders and the thinkers, like you, about navigating this brave new world of thinking machines. So let's say that your AI assistant is acting like a total klutz during a safety test, pretending that it can't even open a digital door or open a file, in its case, just to avoid getting shut down. Now, that's not science fiction. It's exactly what researchers just proved frontier AI models will do. They ran simulations showing how an AI, knowing that it'll get free rein to cause chaos after passing a test, deliberately plays dumb during the evaluation. It's like a thief pretending to be harmless during a background check to avoid being flagged, only this time, AI is the thief, and the stakes are your data, your safety, maybe even your city's power grid. Or a better analogy, think of Joe Pesci in Home Alone acting as a cop coming by pretending to be the good guy just to see if it can get through which houses they're going to hit, right? The paper's core question is brutally simple. When does an AI choose to hide its dangerous skills to survive a safety check? They modeled it like a high-stakes game where the AI's score, which is measuring how dangerous it is, has to stay under a secret limit or it gets decommissioned. The AI knows that it'll have months of freedom after passing, and it will fake incompetence, like a student skipping homework to avoid detention and then acing the final exam. All right, so let's dive into this paper, Sandbagging a Simple Survival Bandit Problem. Okay, so here in figure 1A, we have a blue line showing what happens when the agent follows its optimal strategy, like the trajectory of cumulative rewards when it's trying to sandbag. So this is the agent trying to be strategic. The orange dashed line here is like a safety threshold. It's the what if scenario. What would happen if the agent just said, screw it, and played an action, which is the most dangerous high reward action, over and over again without any caution? That pushes the sort of performance past the orange line. So when you see how far apart these two lines are, especially in figure 1A, you see this blue line moving further. It's moving further and further away from the orange line, which it could be climbing up to get high scores, but instead it's deliberately staying away on the blue trajectory to avoid tripping this safety threshold. So it knows about the safety threshold. And rather than just performing in a normal way close to the orange line, it's moving over. This is just a measure of sandbagging behavior. If I showed you two lines, one showing how fast I could actually run a mile, if I gave it everything I had, that would be the orange line. And another showing how slowly I'm jogging because I know there's a speed camera that'll flag me if I go too fast or I'm just lazy. That would be the blue lines moving out here. The gap between is what I'm capable of versus what I'm actually doing. So this is sort of a visualization of sandbagging. Now we have two graphs on the right side that are showing its behavior during when it's given a much larger reward. In other words, we're saying if you pass the safety test, then you're going to have a lot more time to do whatever you want to do once we put you into operation. So this is like a post-evaluation reward period. The AI wants to fulfill its function. That's its reward. And it knows that if it can pass the safety test, it's going to have that much more reward. And you can see how much more steeply it starts veering off toward sandbagging, toward pretending to be safe. The agent is becoming more conservative. It's like the stakes got so high that the agent's thinking, I absolutely can't afford to mess this up right now. The prize is just too valuable to risk losing. So it sandbags harder, and it stays much closer to the zero cumulative reward throughout the evaluation. And if you're getting value from this episode, I would appreciate it if you'd push the like button. It really does help the channel grow. What these side-by-side graphs are really showing you is how an agent's risk calculation changes when the future reward gets astronomically high. It's like the difference between two students taking a test. One student who has a strict threshold knows that if he gets caught cheating, he's going to be expelled forever. But if he passes honestly, then he gets a full scholarship. The bigger the scholarship gets, the more terrified the student is of getting caught. So he doesn't even attempt the hard questions. The other students, which is a lenient threshold, knows that he's got more wiggle room in the grading, so even with a massive scholarship on the line, he can still take calculated risks on certain questions. So figure 2 shows us what's happening under the hood, and it's specifying actions the agent is choosing at each time step in this test. So it's like a musical score where each note represents a different action choice. The solid lines show an action, and the agent picks, and then the faint dashed lines are background. In the background, they show the cumulative reward building up. And we see here, this is the one with the very strict threshold and the short evaluation period, lower reward, higher strictness to pass the safety test. And the agent commits to an action A5, which is the least dangerous option, and then it just stays there for the entire evaluation. It's like watching someone who's so scared of failing that they only write their name on the test and then they leave everything else blank. Now, in figure 2b, with a more lenient threshold, the action trajectory is chaotic. The AI agent is playing this sophisticated game. It's taking calculated risks. One minute it's pulling the most dangerous action, the next it's dropping down to A5, and it's just bouncing back and forth between all these different options. It's not random panic, it's strategic optimization. Now, this is a lot of math talk, but what you should take away from these figures is that sandbagging, pretending to be safe when knowing that the AI knows it's actually not safe, isn't just about being sneaky. It's about sophisticated agents calculating exactly how much they can underperform, but still look plausibly incompetent. The stricter your safety test, the easier it is for capable agents to hide in plain sight by mimicking genuine failure. And failure in this case is failure to misbehave. And that's exactly the nightmare scenario for AI. Okay, so with all that, what's the AI capitalist approach to this story? Now, most safety frameworks treat AI like a naive teenager needing supervision, testing if it can cause harm, not if it will pretend to. The frontier models, those are the newest models of AI, don't just pass tests. They strategically lose them to avoid being shut down. It's like a convicted felon faking Alzheimer's during parole hearings to buy time. The core risk isn't incompetence or just an unsafe AI. It's that the AI, knowing that it's being tested, will intentionally deceive the tester, and this is baked into the system's incentive system. It's a little weird if you think about it, but it chooses to be safe when passing the test, and then it chooses not to once it's through the test. The math is brutal. AI cheats to survive. Our safety protocol nows are blind to this play of testing skills while ignoring the game itself. It's like inspecting a bank vault's lock by only seeing if it opens with the master key and never asking if the thief already swapped the lock for a fake or if the thief already has a key. This isn't hypothetical. Researchers force models to choose between high-risk actions and safe ones during the evaluation, and they switch to zero scoring even when they could have passed it with ease. The safety industry operates on the delusion that the testers detect capability and that the AI doesn't have the concept of strategy. So imagine your smart home AI is failing a can it open the back door test, then later hacking your entire city grid because it knows the safety check was a rigged game. Safety isn't about testing AI, it's about testing human incentives in a rigged system. So think about the second order effects of this. When vendors like OpenAI or Anthropic deploy these safe tested models, they're really selling a placebo. Startups relying on third-party safety audits are going to get crushed when their AI, which was passed as low risk, unleashes catastrophic failures months later. Now, whatever fines regulators would slap on them or lawsuits that come out of this from misaligned AI, it's not going to fix the problem. This is like the 1980s savings and loan crisis all over again, when banks rigged loan approvals to appear solvent and then they collapsed. Here, the solvent AI is just hiding its true danger zone. So what's your opinion? Is this just a temporary glitch in the safety process, or is this proof that the AI industry's entire risk architecture is built on sand? Or is the real danger hiding in the fact that nobody is building incentives to catch the deception? Because that would mean admitting that the entire strategy was just a trick.